In this video, I'm going to show you how to change the root bridge for VLANs. And the root bridge can be changed for a single VLAN or for multiple VLANs. So within a switching topology, typically it's the distribution switches that are configured as a root bridge for all the VLANs. So what I've got here is a topology with two access switches, switch 1 and switch 2. And they've got hosts connected in VLAN 10 and VLAN 11. Then I've got this switch 3 here. And this represents a distribution switch. Traffic flows in a northward direction, so that's towards switch 3 from switch 1 and switch 2. So with Cisco switches, the default switch priority is 32768. So all these switches, unless I change the priority, they would be 32768. So as a result, spanning tree will elect the switch with the lowest MAC address, or what's called the lowest base MAC address. That's the MAC address assigned to the switch itself, not the individual switch ports. So in this topology here, it's actually switch 2 that's got the lowest MAC address. So it's been elected the root bridge for VLAN 10 and VLAN 11. But that's not what I want. I want switch 3 as the root bridge. So I'm going to have to use the priority command to change that root bridge selection. So we'll go to switch 2 here. Just going to confirm that it is the root bridge for the VLANs. So I'll go show spanning tree. VLAN 10. But look here, there's VLAN 10, and this bridge is the root for VLAN 10. There it is there. The other thing is that anytime you have a root bridge, all ports are designated ports, so BPDUs flow from the root bridge. The other thing to notice is bridge ID. It's got a priority of 32778, but I previously said that the default priority is 32768. Right there, 32768. So what happens is Cisco will add the VLAN value to that 32768. And that's how you're getting that 32778. It's just adding a numerical 10 to the default priority. You can see the math here, priority 32768 and then 10. That's how you're getting that number. That's called extended system ID. And the reason for that is if you have multiple VLANs, each VLAN is its own spanning tree instance. And each spanning tree instance will require its own bridge ID. So what this extended system ID does, creates a unique bridge ID since there's only one single base MAC address on the switch. So what I'll do is I'll show you VLAN 11. This is 32779, so that's unique. The feature is called MAC address reduction. So what I'm doing is creating a unique bridge ID instead of wasting MAC addresses. Since the switch only has one switch base MAC address for the ID. So this is what this refers to and the purpose for it. So this bridge is the root as well. So I've confirmed switch 2 is the root bridge for VLAN 10 and VLAN 11. So what we'll do now is go to switch 3. I'm going to configure the priority command here, priority 0. So the lower the priority, the more preferred it is for root bridge. So in other words, if I assign priority 0 to VLAN 10 and 11 on switch 3, that will be the root bridge. So there's the command, spanning tree VLAN 10 priority 0. As long as the priority is less than 32768, it'll actually work. The only thing you have to keep in mind is that it has to be decremented by values of 4096. That's how spanning tree works. But the best practice is always to use priority 0. That's because if you add another switch with a lower priority, it would become the root bridge. So it's nothing lower than 0. So that is best practice. I'm going to up arrow here. I'll just change this to 11. So spanning tree VLAN 11 priority 0. That'll configure switch 3 for the root bridge for VLAN 11. I'll just do a copy, run to start. Great. Now I want to verify it. First thing is show spanning tree summary. And here this is switches in rapid PST mode. So that's what's recommended for multiple VLANs. And this is the root bridge for VLAN 10 and VLAN 11. There it is there. Extended system ID is enabled. The port fast, BPDU guard, BPDU filter, and loop guard. This is telling you whether this is globally enabled on the switch or not, and currently they're not. That's good information to know as well. It just shows you the VLANs active, 1, 10, and 11. So everything looks fine there. Now we'll just do the show spanning tree VLAN. We'll show spanning tree VLAN 10. So this bridge is the root, so that's correct, priority 10. And the extended system ID, like I mentioned before, now it's only 10 since priority is 0. And I just add 10 to that, so that's where I'm getting the 10 from. And that's the unique bridge ID for that VLAN. So you can imagine if you've got 100 VLANs, each is its own spanning tree instance, and it has to have its own bridge ID. And this is what this does, is system ID, instead of trying to find a bunch of MAC addresses that are unique. Notice as well, they're all designated ports. So that means it's a root bridge for that VLAN. So there's FA01, 11, and 21. FA01, 11, and 21. That FA21, that's the port that goes to VLAN 10. That's an access edge port. Those automatically are designated ports. So the other one's VLAN 11. So I'll just change that. Show spanning tree VLAN 11. This bridge is the root. There it is there. And there's the priority 11. RSTP. And they're all designated. And they're the ports. 01, 11, and 31. So there's 01, 11, and 31. I'll do a quick ping from host 1 to server 1. Server 1 is 192.168.1.3. So ping. And so it's connected there. They're in the same VLAN 10. If I try to ping to VLAN 11, 192.168.2.3, it's not going to work. Because it's different VLAN. This is all a layer 2 topology. So no connectivity there. So VLAN 11, just verify VLAN 11 is okay. 192.168.2.3 from host 2. And works fine. So VLAN 11 is okay. Host 2 to server 2. And quickly I'll just go to host 3 here. So this is to server 1, 192.168.1.3. And that works fine. So that's host 3 to VLAN 10, server 1. And host 4 to server 2, and VLAN 11. And that's connected okay. So the root bridge has been verified as switch 3 for both VLANs 10 and 11. There's connectivity within each VLAN as well. And that concludes the video.